Beyond the mere fact that the Earth does revolve around the Sun, what else do we know about this motion? First off, we know that the planets revolve around the Sun in elliptical orbits, or paths, rather than circular ones. Johannes Kepler is responsible for this discovery. He was also responsible for several other key discoveries involving Earth's celestial movement. Kepler also established 3 laws of planetary motion. The first law, which we've already mentioned, said that the planets move around the Sun in elliptical orbits. The second law said that the planets move through space faster during the periods of the orbit when they're closer to the Sun. And the third law said that the planets that are further from the Sun have longer orbits and take longer to revolve around it. Basically, they have longer years. Kepler based these theories on years of collected data, but he never understood why the planets orbited the Sun in this way. Sir Isaac Newton clarified Kepler's discoveries when he explained how gravity worked on objects. It wasn't until Einstein that physicists would understand what gravity was, but Newton explained how it worked and how it affected matter. Newton established this law with his law of universal gravitation, which states that the force of gravity between 2 objects depends on the masses of the 2 objects and the distance between them. Greater mass means a stronger attraction, and a greater distance means a weaker attraction. So large objects that are close have a strong attraction, but small objects that are far apart have a minimal attraction. Since gravity works as an attraction between 2 objects, rather than of one object to another, both objects are influenced by the force. The smaller one just moves more than the big one. This explains why the planets have elliptical orbits. The gravity between the Sun and a planet causes the Sun to move, just not as much as the smaller planet. This also explains why planets move faster when they're closer to the Sun. The distance between them and the Sun has decreased, so the gravitational attraction has increased. Newton's law of universal gravitation filled in the missing pieces in Kepler's laws of planetary motion. Gravity actually works with inertia to create the elliptical motion of the planets. Inertia is an object's tendency to resist acceleration, or basically to continue in whatever state of motion they are in. So the planets all want to continue moving in the direction and velocity that they had when the solar system first began to form. This forward motion, coupled with the tether of gravity, creates orbital motion. If you picked up a rope or grabbed a pair of shoes by the laces and began to swing them around your head, they would go in circles, revolving around the part of your hand gripping them. If you let go and remove that force holding them to the center, the rope or shoes go flying in a straight line, because now only inertia is directing their motion. In the case of the planets, gravity is that tether keeping the planets going around the Sun rather than flying in a straight line out into space as their inertia wants them to do. Objects in the room don't revolve around you because that gravitational attraction is too weak to cause them to accelerate around you. You stick to the ground rather than orbiting the Earth like the Moon does, because no matter how fast you move, the gravitational attraction between you and the Earth is too strong for you to make it around the planet before being pulled back down. But if you increase the distance between you and the planet and decrease the strength of gravity, then small objects like satellites and space stations can orbit. We didn't always know that the Earth revolved around the Sun. The first theory that comes to mind when one looks up and sees the Sun and stars moving across the sky is that they're smaller objects moving around us, and society held this belief into the 16th century. This geocentric model was the accepted truth for the bulk of human history. Aristotle proposed one of the first such models, and later a mathematician named Claudius Ptolemy improved upon Aristotle's model, developing a model that actually predicted the position of the Sun and all of the planets through an intricate system of loops and spirals. However, science is based on pragmatism, the idea that the simplest solution that accurately explains the observed data is probably the best one. In the 16th century, Nicholas Copernicus proposed the first realistic heliocentric model of the solar system, moving the Earth away from the center of the system and placing the Sun there instead. This simple readjustment was able to explain the positions of the planets and Sun at all times of the year, and do so without all the complex motions required in Ptolemy's model. It was far more pragmatic and slowly began to win over scientific minds around the world, greatly aided by the telescopic observations of Galileo of the solar system and the books he published championing a heliocentric model. It took a long time for the world to accept this model of the solar system, but the works of Galileo, Kepler, and Newton went a long way to earning it public acceptance.